wherever you are. I'm Ravindra Bhatta, and today we are representing Texas Tech University as a part of this IEEE PES Day 2022 celebration. And today we have our speaker, Robin Dhaka, who is currently a PhD candidate in Department of Mechanical Engineering at Texas Tech University. He got his undergraduate degree from Pulsar campus, Turbine University, Nepal. He got his master's in mechanical engineering from Texas Tech University and has been working in research and development works in distributed energy system since 2014. He has more than over 20 peer-reviewed technical papers in prestigious journals and conferences, and also served as a reviewer for different renewable energy journals, including Renewable and Sustainable Energy Reviews and Renewable Energy. So today, we'll be talking about the research and practice on distributed renewable energy resources. And now I'd like to hand over the seminar to Ravindra.
Okay, thank you very much, Ravindra, for the invitation, and thank you very much, IEEE Power and Energy Society, Texas Tech chapter. Okay, so then I will share my screen. I think you have to like provide me the permission for to share the screen. I think if you can make me host, that will be fine. I can control everything. Yeah. Okay. Okay. Thank you, Ramesh. Okay. So you guys can see my screen, right?
Yeah.
Okay. Okay. Thank you. Okay. So I don't want to go with my introduction. Okay. Let's move on to the. Okay. Okay, so today I will be discussing about distributed renewable energy system based upon my experience of my undergrad degree, and after that few years of experience working in the industry, and after that I joined Texas Tech University for the PhD program, and I continued my research in distributed renewable energy system. So during my undergrad, you can see the first picture where I work on micro hydropower system. I do some research on micro hydropower system, which is distributed renewable energy system. And after that, I try to commercialize the research finding which I have made during my undergrad degree. And I have little R&D entrepreneurship experience as well, in which I have worked on solar, wind, and hydropower system in Nepal and other parts of the world as well. And after that, I came to United States for my PhD, where I am conducting research in solar power based system and wind power based system. Obviously, we do not have much hydropower resources in the United States. That's why I'm not able to continue my research in hydropower sector. And after that, I will be talking about opportunities and challenges in this field. Okay, so let's discuss about what is micro hydropower system. So this micro hydropower system, it is also a distributed renewable energy system because it is typically in off-grid in nature. We have to form our own transmission line, like power and control system, all other things we have to make our own. So that's why we can say this is also a distributed renewable energy system. So here in typical micro hydropower system, we have some kinds of intake of water from the flowing river or maybe reservoir, and we have some system to direct the water to the powerhouse where the turbine is situated. So in this way, the power is generated from the turbine, which is typically at maybe 20 to 100 meter from the source. I mean, it is usually called four-way tank in the real pipe hydropower system. This is typically the bigger hydropower system, which is at right side of you can see on right side. This is a typical hydropower system, but usually in micro hydropower system there may not be every component. In the purpose of micro hydropower system is to generate a small scale of energy, and where all the infrastructure are not that much robust as the bigger hydropower system. So I work on this micro hydropower system, but not the what we see previously. I work on, I think I will make these participants allow participant because some people are coming. So let's wait. Admit. Okay. I think what I have to do is enable waiting room. Okay. I think now everyone can participate here. Okay.
Okay.
Yeah, where I am. Okay, I'm here. Okay, so I work on this gravitational water vortex power plant, which is a micro hydropower system. It is a ultra low head hydropower technology. Typically, the micro hydropower system require head up to 25 meter, up to like 100 meter. But for this micro hydropower system, we only require 1 to 3 meter of head. And it consists of canal, basin, and turbine. And this structure, this round structure is called basin. And this one where the water flows, we can say this is a canal. And then at the center of the basin, there would be like turbine. So how the turbine works is water going through this canal is tangentially fed into this basin structure so that the water vortex is formed. So this water vortex is that much strength that it can rotate this turbine, and we can extract power from this rotating turbine. So here the main source of power is a water vortex, not the head. Typically in other micro hydropower system, head is the main source of energy, right? Where if we have some kinds of head difference, so due to the gravitational force and the flow of the water, energy would be extracted. We know about the common formula like rho QGS. So from that, the power is extracted. But here, the main source of power is not the height. Here, the main source of power is the water vortex, the strength of the water vortex. So this is a turbine which I work in my undergrad degree. It has, I already discussed, it has head range of 1 to 3 meter, and it has flow range up to 300 LPS, and it has maximum efficiency up to 80%. And from the installation around the world, we can see the installation up to few kilowatt to 26 kilowatt of installation. So it is very less amount of energy. So what was my research objective in my undergrad is to optimize the design parameter of the turbine. Here are some geometrical parameter we can see here. And second objective is to select a suitable runner. So this is a kind of new technology which was introduced in the world in the year 2007. So there has not been much research at the time. Means in 2013. I work on this project in 2013. So there has not been much development in this field. So that's why I work on this optimization of design parameter and selection of the suitable turbine for the runner. And the major research finding which I have made is we can find this in like 2 of my paper. One is a journal article in Renewable and Sustainable Energy Reviews, and another one in conference. Where in the first paper, where I have found out the optimum basin structure, that is previously cylindrical basin structure was used for the production of the water vortex, but I propose to use conical basin structure for the formation of the vortex. So it will give much greater vortex strength so that we can get much more power in the hydropower system. And another finding in the design is the optimum position of the runner. So where the runner should be located at what height of the basin. So that also I found out, and this can be found out in this journal article. And the second one is I also conducted the computational and experimental study on the runner, different profile of the runner, and also the different number of blade. So from this runner, I have proposed a suitable runner with a curved blade profile and having 4 number of blade. So I don't want to discuss much about like technical detail about the computational things. Yeah, because we are a general audience here, right? So yeah, so those are the research finding, and after that I just have a couple of few 1 years of research experience. After that I really want to commercialize those things because it's a kind of new to the world as well, because only few installation has been made and those are of cylindrical basin structure, and I am proposing the conical basin structure. You can see this conical shape, right? So previously only cylindrical basin was installed in a different part of the world like Austria and many other part of Europe and Africa. So what I did is after that I published few paper and people started believing in that technology because I published in a really prestigious journal which is like rank 1 in the world, renewable and sustainable energy. And after that I organized few conferences to disseminate the knowledge which I have gained by the research. And then I also like write article in different newspaper and other things in Nepal. And then I try to convince them that we should commercialize it. And after 1 year of this kinds of struggle, I got some kinds of funding, and I did one pilot installation of this turbine with 1.6 kilowatt of capacity, which you guys can see here in a river in the capital city of Nepal. And then I saw that we can extract power from this micro hydropower system. And after that, after finishing my undergrad degree, I worked about like 4 to 5 years in Nepal in different renewable energy sector. The main purpose of my entrepreneurship journey is to commercialize that turbine which I worked during my undergrad degree. I was working part-time in university and also work in my own company to commercialize this research. But while working on this commercialization, I work in different other types of renewable energy sources as well, because people started to giving me such projects. So I work on different other renewable energy sources like solar power sources and wind power sources as well. So what are the opportunities in Nepal? Not only Nepal, I'm talking about developing countries. I believe we are not the audience from US only. So I think I also want to discuss about this topic as well. So in developing countries, usually most of developing countries, we do not have electricity in all places. So there are some places where we can use this technology, these kinds of renewable energy technology, and electrify the community, because it is the technology which is only for like some 100 to 200 household. This is like distributed energy sources, so we can install those in those areas where they need electricity. And also talking about Nepal, which has like tremendous source of renewable energy such as water power sources, solar and wind power. So we can install any location in such country. Unlike USA, we do not have much potential. We only have potential of wind and solar, right? But here in Nepal, there are like potential for all kinds of renewable energy sources. And the thing is, if we have new technology, there would be like less competition, because in the developing countries, there are like less people who are working on the new technology, because they rely on the technology which were imported from other countries. So there will be less competition. So these are like opportunities in developing countries. And also the funding agency are interested in developing countries, because in the developing countries like Nepal, we don't have to make a project profitable, because where there is no electricity, the providing electricity is the biggest thing, right? We don't have to make the project profitable, economically viable, or such things, right? So we can it is a kind of socialist development concept, so we can pull funding from different funding agency and we can make our project. So that's it. That is a benefit working in a developing country. Okay. So here are some pictures which I have worked in different mountainous region in Nepal, and there are like pictures of site survey and photovoltaic installation on different hilly region of Nepal, and feasibility study of wind energy sources in one of the mountainous region of Nepal. Okay, during that time, I also collaboratively work with academia and industry as well, because I was working as a lecturer in a university. So I work with my own company and academia and other research institute as well. So it is really very important, because whenever you are doing R&D entrepreneurship, people do not believe if you are just working alone, if you are not working with academia or any other prestigious research institute, they would not believe you and they do not fund you. So the benefit of working with academia is people will rely on your work and they will also try to fund you as well. So that's why I work with academia as well during the entrepreneurship journey. So during that time, I also work with technical and economical analysis, because I really want to install those projects in the real field. That's why I have to do the technical and economical analysis. So for this water vortex power plant, what I propose is, if we have to make everything from the beginning, the cost of installation would be higher. So no one would be interested. If I try to make it cheaper, where if I try to install it in the existing water infrastructure, like where there is already wire structure, where there is already a reservoir system, or where there may be already canal. So in this type of structure, I propose to install those, so that the installation cost would reduce to like half of the total cost. So I work on these types of research, which is like a real field research, not like the research on the paper. So I work on these types of research as well in that time. Okay, so after in 2018, a South African company, they invited me to install this turbine in their country, and they typically want the feasibility study initially, and they want to develop such project in different location of South Africa. So I went there, and what I learned from that is, in the developed country, means like USA or maybe South Africa, we can say it is a first world country, right? So it's a developed country where there is no place where there is a lack of electricity or any power sources. And but the opportunities is that because in that time the electricity prices increased rapidly in South Africa, and the renewable energy source can compete with the existing energy sources. So that is the opportunity in developed countries. And RE-based system would be like cheaper than the others. So we did the technical and economical analysis, and from the economical analysis, we conducted that we had a conclusion that RE-based system would be like cheaper if we can install the RE-based system. But the main problem is there are like few opportunities for RE-based system. There may be opportunity for the solar-based system, but not the wind and hydropower system. But I only work in hydropower at that time, so there are like very few chances of installation of such turbine. But we had some opportunity there. This is a site in South Africa, where this is a site which is just beside a resort. So what the resort want is, they want their own off-grid system, so that they can utilize the river which just flow beside their premises and extract energy from these types of flowing rivers. And in South Africa, we cannot find the river with high head, so they only have the head of like 1 to 2 meters. So this is the only technology which is feasible for that. So that's why they invite me. So this is a kind of opportunity there. So different private organizations, they want to install such off-grid system, distributed energy system, and they want to rely with their own renewable energy sources in that time. So there are some preliminary design concept which we have made in South Africa. And this project is now in final stage of construction. I want to show a video where they have already made the basin structure. So this is our preliminary design, and we have already made this basin structure. On the top, it seems it is right. So from the top, it seems it is a conical cylindrical basin, but it was conical basin structure. On the deep, it is conical basin structure. That's why the strength of vortex is maximum. So I think that project will be in function maybe next month. Okay. So that's all about what I did in my undergrad, and after that, my 4.5 years of entrepreneurship, R&D entrepreneurship journey in Nepal and other parts of world. So after that, in 2019, I came to United States and start working on different research. And I want to continue my research in distributed renewable energy system. So I collaborate with NIW, National Wind Institute, and RIS Technological Center, where they have some microgrid facility. And I, in graduate study, I work on different solar power system. I have conducted different technical and economical evaluation of installation of solar PV system to make the educational building, net zero educational building. And I have worked on different wind power system. Here it is, we can see this is a Weibull distribution curve. I work on different wind power system, like resource assessment of wind power system. And I have also applied different machine learning technique. This is LSTM network. We can see this LSTM network, and I have implemented different machine learning algorithm in the wind resource assessment and wind power production. And another interesting project which I want to discuss with you today is this mobile wind turbine unit for the emergency situation. So this I will be discussing with you in detail. The concept of mobile wind turbine unit is because whenever there is hurricane, usually in Texas, hurricane is most popular and frequently happen, right? So hurricane or maybe earthquake or any other like extreme event, there will be obviously a power cutoff. There is chances of power cutoff. So the chances of power cutoff, and we have to mitigate it, and we have to respond the power outage, and we have to supply some kinds of emergency power supply before and after the power is fully restored from the typical grid supply system. So during that time, we can take the advantage of this distributed energy system, so we can make the power readily available during that event as well. So I started working on it during my master's. So I have already discussed, we have to prepare for the event because hurricane is most popular in Texas. So we have to prepare whenever the hurricane will happen. We have to supply some kinds of power to the grid, or maybe to the affected household. And during this during event, this red marks, in this time, we can supply the power through such kinds of mobile wind turbine unit. So this is the concept. And okay. And while talking about the practice, the use of renewable energy resources is not very common. So why it is not very common? Because usually the fossil fuel generator are used because we can transport those fossil fuel generator easily. And then another thing is renewable energy resources is not stable. That is not static, right? So we cannot transport those stuff. Or maybe we can have a solar PV system, but it will not work at night time or maybe another time. So, but wind is not that much feasible in such location. But we try to make the mobile wind turbine unit, and we try to utilize only the height of 10 meter only, so that we can make the wind turbine structure mobile. So it would be not the ground structure of the wind turbine system would be not that much robust, so that we can install that turbine in a truck, and then we can go to the place where there is hurricane or maybe earthquake or any other extreme event, and we can supply power to the community. So this is the concept. Yeah, I have already discussed the ground structure should be less.
Sorry to interrupt, but we have a time limit of 9 minutes. Just to let you know.
Okay, I got it. Yeah. So it will finish in like 3 to 4 minutes, and then we can discuss later. Okay. Thank you, Ravindra. Okay, so yeah, the ground structure should be less, and it should be mobile or emergency in nature, and we can only get the power from the low hub height, because if we want to go to the high hub height, we have to make the ground structure very robust, right? So we can see in the Texas it would be like only 3 to 4 meters per second. So for these types of system, unlike the horizontal axis wind turbine, we propose to use the vertical axis wind turbine like this, because we are only working on the height of 8 to 10 meters. So vertical axis wind turbine can be mobile than the horizontal axis wind turbine. So we propose this, and we are working on it, and we are also trying to get one prototype model in RIS Technological Center, and then so this can be feasible in supplying power during the emergencies. Okay, so what are the opportunities and challenges in USA? I'm talking about in USA now here. There are lots of opportunities of these types of distributed renewable energy system, because here it is a kind of cost effective in many areas in USA in terms of like solar PV panels and some small scale wind turbine system, and some businesses as well. It is cost effective than the energy which they get from the grid. And also the government and state level government are also advancing the policies to encourage the development of such distributed renewable energy system, and they are also providing some kinds of tax benefit and other stuff to promote it. So that also we can consider as opportunities. And also I have already discussed during the power outage, applying these kinds of distributed renewable energy generation make the grid system more resilient, and also it will have more security in during that time as well. Yeah, so these are the opportunities of distributed renewable energy system in USA. And also for if we have a typical organization or maybe educational building, we can make it net zero building without using any other power sources from the grid. So that is also another opportunity. And there are like many resources going on, such making the building net zero, and such kinds of stuff we can do in the distributed renewable energy field. Yeah, here are some of the references which I have used for this presentation. Yeah. So yeah, because we only have 5 minutes now to discuss on any question. Thank you very much, everyone, for listening to my presentation, and thank you for Ravindra and IEEE PES Society for giving me opportunity to share my research work with you all.
Yeah, thank you, Robin, for your very informative session. It was really interesting to hear about your research. So I would like to see if there are any questions. Yeah, just to touch upon an interesting topic that you pointed out. So how do you see the future of renewables in developing countries like Nepal and so?
Yeah, while talking about, let's first of all talk about USA. In USA, the Department of Energy, they are targeting by the end of 2050, there will be no fossil fuel based generation. That is a target. Maybe like it will be maybe 60% would be fulfilled. And while talking about New York City. In the New York City, they are removing all the fossil fuel generator by the 2030. And one of my friend, he will be losing his job because he is working in he's a mechanical engineer and he's working in like fossil fuel generation things. So that there will be like much opportunity in renewable energy sector in USA. And while talking about Nepal, Nepal is itself is a country with tremendous renewable energy sources like hydropower, solar, and other things. So we can do a lot of things in renewable energy sector in Nepal as well. Yeah, thank you very much for your question. Nice question, Ravindra.
Yeah, let's see if we have other questions.
Hi, I have a question. So why do you think there's less excitement about the hydropower in United States compared to the developing countries like Nepal? Is it because of lack of resources, or is there some sort of reason for behind it?
Yeah. Thank you very much, Ryan. Actually, yeah, the first thing is there is lack of resources as well, because we cannot find lots of rivers which having head, right? Because for the development of hydropower, we need some kinds of head in the river. We should have some head difference from intake to the powerhouse, right? So there are like very less river. And another thing is now solar power system is competing with all other renewable energy sources, right? Because it is becoming cheap, like the solar panels and all other stuff, they are like becoming very cheap. So while comparing to the 3 renewable energy sources, now solar is leading among all other renewable energy sources in the United States. That's why I think they want to focus on solar and wind than the hydropower as well. That may be another reason.
Yeah, it might be because of the cost as well, right?
Yeah. For the development of hydropower, it will like the cost will be like really high comparing to the like solar power and wind power system. Yeah.
So, hi, good afternoon, good morning.
Good afternoon.
Thank you for your presentation. So actually, I have a question.
Yeah, sure.
Did you mention the vertical axis turbine as a proposed model, right?
Yeah, correct.
So what kind of phenomenon are you studying compared with the horizontal turbine that we know a little bit more during a natural disaster as a hurricane?
Yeah, thank you very much for your question. Actually, for now, we are just working on how we can transport the turbine to the place where there is like emergency events. So that is the main purpose. So if we talk about a vertical axis and horizontal axis, we have to transport the wind turbine blades and the tower like at different trucks if we talk about horizontal axis wind turbine, because we have to install the turbine there, right, in the place where we will transport there. But for the vertical axis wind turbine, we are just working on like very less height, maybe like 8-meter height. So for the transportation purpose, this is easy. For now, we are just working on the numerical study, how much energy we can extract from the vertical axis wind turbine in comparison to the horizontal axis at the height of 8-meter. And if we find they extract same amount of energy, we propose vertical axis wind turbine, because it can be easily transport than the horizontal axis wind turbine. So this is the main purpose. Thank you very much for your question.
Yeah, I think we are almost out of time. So I'd like to thank Robin for your time. And I think I'd like to thank all those participants for joining this presentation today. So yeah, thank you and have a good day today.
Thank you. Bye-bye.
Bye.